today. I'm Ramtin Rampour, and today we're going to just quickly talk about the Opengear solution overall and how we can manage, remediate, and deploy your edge environment. So let's jump into it. First of all, let's take a high-level overview of the edge. I'm sure you guys have all heard over and over during the event. Essentially, what is the edge, right? It's such an amalgamous thing. In reality, it just is. It has to have a centralized aspect. So the way you look at it is, you have your data center, you have your core, and then you have the edge sitting somewhere. It could be the building next door, it could be a closet, or it could be, thousands of miles away in a office. But essentially, at its core, what all the edge locations share is a centralized cloud element that they reach back to for connectivity. Obviously, 5, 10 years ago, there was a lot of conversation about the shift to the cloud, right? Everything is in the cloud now. And that comes with its challenges. Some of the more common challenges from the edge versus the cloud is increased latency. So every time you want to pass traffic from the edge to the cloud, there's a latency factor into it. Now, that can come into effect with things like giant warehouse and robots, and they need to do processing to take actions to not run into a human being if there's a robot that's moving forward. You don't want those decisions made at the cloud because that's going to increase the latency and you can have a bad accident on your hands. Another thing is regulations, so HIPAA compliance, things that you want to host inside your own hospital or on premises instead of having to ship it all the way to the cloud and risk security. Lastly is just the cost of moving data. So it's expensive to ship everything upstream. It's expensive to ship firmwares downstream, right? So it costs money to move data, hence why a lot of streaming services are now having little mini edge pop-ups everywhere to make sure that they can feed streaming data to their consumers without having to constantly go back to their core location. And obviously, edge is essentially an architecture of how data is actioned where it's generated. So whether it's on a computer, whether it's on a robot, as the data is generated, what do we do with that data? Do we send it all the way to the core? Do we secure it on premises? How is that treated? And then edge, regardless of how many devices you have, you still need some kind of an infrastructure, whether it's a router, whether it's a switch, whether it's a simple 1U NUC that's sitting there, or even a table NUC that's sitting there that's doing your calculation. So it's important to remember that regardless, you need infrastructure at the edge. So as an out-of-band company, as a smart out-of-band company, how does Opengear and how does out-of-band come into play at the edge, right? So you obviously always need secure remote access to your infrastructure, and that this means whether you're in-band, your regular broadband connection, or whether you're out-of-band over cellular, you want to be able to have visibility to these devices. We've heard it over and over again during this event that smart hands are hard to find at the edge. So when you don't have a smart hand at every edge location, or if you have a distributed edge with thousands of locations, and you can't have a network engineer, you can't have a technician at every single one of these. So you want to be able to automate things to a point where you can be the smart hand, but not physically be there. And obviously, you want to be able to provision things on a day zero basis. So that means that you deploy a new device, you deploy a whole brand new NUC, your switch, your router. You want that to be able to deploy with ease. And long term, you want to be able to handle RMAs, right? So what happens when your firewall goes down and you have to replace it with a brand new one? Well, somebody has to still go and minimally program that brand new firewall so it can call home and get the rest of its configuration. And those are the things that we're trying to address by basically having an out-of-band solution on premises. Obviously, storing configuration and operating system, iOSs and OSs securely is another big factor when it comes to out-of-band management deployed at the edge. And what we mean by that is you can have shadow IT devices sitting there hosting an HTTP server or hosting a DHCP server to actually provide connectivity and provide files. But are those devices secure? Can somebody grab and run away with them? Or are you spending a lot of compute power to host something that can be hosted inside your out-of-band device? And more visibility from the most resilient device on premises. What do we mean by that? So I have a device here that we'll talk about a little bit later. But what we really mean is the devices that we build are built with resiliency in mind in every aspect, whether it's multiple network interfaces, whether it's cellular failover, whether it's ensuring that there are two SIM slots in case one of your accounts lapse and you lose connectivity, and having dual power. So essentially, at every corner, we look at resiliency to ensure that the device is staying up constantly. You also don't want to rely on your network to manage your network. When you're talking about out of band, you want something that you can have has a reliability in case your network goes down. So this is kind of why we think that when a lot of a lot of companies out there are deploying their out of band solution inside the same UCPE that they're deploying all the other tools, all the other network functions. Well, what happens when that device fails? Now you completely lost connectivity to your network. You lost that resilient, redundant path. And lastly, we're essentially the network when there is no network. And what we mean by that is because we have the cellular functionality, if your broadband connection is not in yet, you're able to actually utilize our cellular connectivity to bring up the rest of your network, whether it's a manual effort of connecting in and configuring your devices, or whether it's an automated effort to essentially have our centralized access portal push down configurations over cellular and bring the rest of your network up. And in reality, to Opengear, it really doesn't matter. It doesn't matter whether it's an edge, it doesn't matter whether it's a core, data center, serial, IP, VNF. We're basically able to provide that connectivity. All right, so let's take a look at our motto, essentially. So the Opengear solution provides the deploy, manage, and remediate of your edge locations. And traditionally, out-of-bands have always been affiliated with the remediation, right? So we're there to solve a problem when something happens. But as technology has progressed and we see all these use cases at the edge, we realize that we can actually help you with the deployment and the long-term managing of your equipment over time. So let's go ahead and jump into what we mean by that. So with the deployment, zero-touch provisioning has come up a lot. What Opengear does is we can actually zero-touch provision our own devices, as well as provide zero-touch provisioning functionality for your downstream devices. Again, whether they're switches, routers, whatever you needed, we're able to provide that. The way I like to imagine this is with the Opengear solution, you're laying down the piping, right? You're laying down that alternate piping, that connectivity, that resilience path that you can access in case something happens, or on your first day to actually bring up the rest of the network. You're also saving time, as I mentioned, with the cellular-enabled smart out-of-band, meaning that you can constantly have availability to your network, even when the broadband connection hasn't been installed. A lot of our customers actually use us to provision their environment without even having to worry whether the broadband has arrived at the edge or not. Or the broadband has arrived, but they don't trust or they don't have the smart hands on site to be able to do the configuration. So they just ship an Opengear, they do the full configuration stack, and then everything starts coming up and connecting to the core. Manageability. Now, what do we mean by manageability, right? So you've deployed it, you used our out-of-band solution. Typically, at this point, a lot of customers would just say, okay, we're just going to let the device sit there in case something goes wrong. But with the new platforms that we offer and with the complete solution, you have a lot more that you can do with the product. Whether it's the presence and proximity to your devices, which means that you have network connectivity that you can reach, you have serial connectivity that you can gather logs from, to being able to host some compute software. So we have an embedded Docker, so you can actually host a ThousandEyes container, a DHCP container, and we'll get into those a little bit later to continuously manage and monitor your network as using the out-of-band solution, right? It's an independent path. It's an out-of-band path that's not using your regular in-band connection. And then obviously everybody's familiar with the remediation, minimize the worst day, be the superhero. As soon as something happens, jump in, whether it's through cellular, whether it's through in-band, connect through serial, and actually resolve the problem quickly. Starting take a quick look at our platform. So our platform essentially all starts with our Lighthouse, which is our centralized secure access portal. And from there, you have secure connections, whether it's through in-band or cellular, to Lighthouse from each physical devices. On the right, we have more smaller port density devices that are usually for edge or branch sites. But in reality, there are a lot of branch locations that will require more than 6 serial ports or 8 serial ports on a per device basis. So even though we title them edge and branch, really in reality, an edge can have hundreds, if not thousands of switches, just because the edge is not about the size, but it's about essentially location to the cloud. All right, and I'm sure everybody's familiar with the console and RS-232 and serial. So we want to kind of focus more on the IP-based, resilience-based workflow. So at the top, you can see there's some common applications and automation workflows that we have, that our customers have used in the past and we assist with. Embedded into our products, both Lighthouse and our physical hardware, is you have your Python and Docker containers, right? So you have Python embedded, so you can run your Ansible playbooks, you can run particular scripts and libraries, and you have Docker, so you can actually host some simple or not so simple compute software. So a great example of that again is Thousand Eyes. We'll get into more examples down the line. The next part of this layer is your centralized access, right? So everybody has one, and the reason for that is you don't want to individually manage your every single Opengear device, or you don't want to jump into every single piece of hardware one at a time in order to be able to manage it or the devices downstream. So we basically use Lighthouse as your centralized node manager for the Opengear devices and your centralized portal to be able to get to your downstream devices. And again, your devices can be a console device, or it can be an IP, it can be a NUC, it can be a switch router, whatever it may be. At the physical layer, we have all of our appliances. And in this example, we have our operations manager and console managers. These are the ones that enable your ZTP functionality, give you that out-of-band management and remediation when you need to. And obviously, the managed infrastructure will be all of your infrastructure that's deployed at the edge, whether it's a PDU, a switch, a router, or whether it's just a virtualized environment, whether it's a VNF, whether it's Windows running on a NUC. Those are all the things that we connect to.
Or is it private between effectively the edge device and in itself? Like, could we use it to orchestrate things and or send commands downstream?
Yes to both. So it does. So the Lighthouse and the console server, or the operations manager and all of our appliances do use API to communicate to each other to make configuration changes, deploy scripts. But we do also expose APIs on both the appliances and Lighthouse, where you can jump in to make configuration changes, deploy scripts, whatever you need to.
Right.
Quick overview of our hardware. So essentially, the way we look at it is you have your performance-based appliances, which are your operations managers. They are based on a platform. They do a great job with most, if not all, Docker containers. You can put in your own custom Docker containers. And they have the capability to be anywhere from 8 to 48 serial ports with a variety of Ethernet port density from 4 all the way to 24 Ethernet ports. And then on the left, we have more value-driven devices, which are essentially focused on the cellular out-of-band, failover, and enabling you to have console connectivity to your devices.
Question: Are these newer devices? Are they in the past year, launched in the past year, past couple of years?
The CM8100 has been was launched last year, and then we just announced the 10G model. Because a lot of data centers and hyperscalers just don't have a 1G interface anymore. So the operations managers have been around for about 4 or 5 years, and then this ACM one has been around for, I want to say, 10 years roughly.
Okay, thank you.
You've heard the term Lighthouse a couple times, so let's quickly talk about what is Lighthouse. Essentially, it's your centralized portal to access all of your devices and manage all of your Opengear appliances.
Oh, so this is an appliance you provision yourself. It's not a SaaS product from Opengear. You actually provision your own instance?
Correct. You provision your own instance. The different hosting options that we have, obviously you can do it in VMware, VirtualBox, Hyper-V if you want to do it somewhere local or in your own core or data center, as well as cloud options such as Azure or AWS. One of the small demos that I'll be doing, I'll be connecting to a Lighthouse that's just simply hosted as an EC2 instance on AWS. Now, again, the point is, Lighthouse gives you that connectivity. We talked about it a little bit earlier. You don't want a device that you don't want to be able to manage. You don't want to have to manage every single one of your devices one at a time. You only have so many hands, so being able to put everything in a single bucket makes that much easier for management. And again, it's also your portal to be able to access your downstream equipment. So I have a device here. I'll start handing it out. I'll start with you if that's okay. So this is our OM1200. So this is technically an edge device or a branch device. But as I mentioned, every single location is different. Every single closet has a different set of port densities or different number of equipments. So just because we call this a branch doesn't mean that it's any different than our higher density devices. All the operating systems are the same. It's just a different form factor. So one thing to remember with these devices, I'll jump to the next slide that kind of talks about the actual physical aspects of it. The x86 processor, this particular device has 4 gigs of memory, so we have devices that have higher memory, and this one has 16 gigabytes of storage. The bigger operations managers have about 64 gigabytes of storage. So it really depends on what you're trying to do. We've had customers that, again, we talked about it a little bit earlier, where hosting something as simple as a firmware on the operations manager means that you have to push down the firmware a single time. So you're pushing down the firmware once. The firmware is sitting on the operations manager. Now, if you have to provision 100 different edge devices, you essentially are set to go with a single, by pushing down the firmware only once, instead of having to worry about pushing down the firmware 100 different times and consuming that data that we're so concerned about at the edge.
I've got a question.
I'm sorry, go ahead.
I know you're a Digity company. Does this support band 48, private CBRS band?
This particular module does not provide band 48, but I can get some information about some of the newer modules that we're looking at to see if that supports it.
Cool, awesome, thank you.
No problem. The firmware on these are all API-based, so back to your point, everything is API-driven, meaning you can configure the entire thing end-to-end through API. We have the embedded TPM. That comes up a lot. As a reminder, these are all designed in-house and manufactured here in the US in our Sandy, Utah facility. And the reason the TPM is so important is, as we talked about, we enable the zero-touch provisioning at the edge, which means that we have our own configuration to worry about, but more importantly, your configuration, your devices' configurations and operating systems to worry about. And we essentially ensure that all of the customer configurations and the Opengear configurations are all secured at under that TPM chip. So this way, if somebody takes the device, they get nothing. Just a quick overview of the physical ports. You have a shared SFP and Ethernet port on the left, usually connecting to your WAN or LAN connection, followed by up to 8 serial ports that you can connect to your switches, routers, your console ports. After that, you have 8 Ethernet ports. Again, these are all Ethernet ports that can be broken down to single individual interfaces, or they can all be part of a bridge. They can, partake into a OSPF group, or just be in a single VLAN. It's all up to you how you want to design your infrastructure. And we have some Ethernet USB ports. And these USB ports are super handy if you want to quickly pass over a file, provision the device, or if you're looking for extra console ports, you could technically plug in one of the USB to console adapters and essentially turn these or convert these to a console port. On the other side of the device, we have 2 redundant power supplies. The reason we did this is the edge and the data center. Power is always an issue. What happens if there's a bleep of power? What happens if the PDU goes bad? We ensure that by having 2 redundant power supplies, the device is always up until the site is completely dark. We have 4G antenna connections. There's a main and aux, and then GPS. not a lot of customers use GPS, but we have had them use it in the past to track where their buses, where their trains, where their ambulances are at all times. And we can feed that telemetry data back to you. And then obviously dual SIM slots. So you can choose 2 different carriers in case a Verizon network goes down, you can jump on T-Mobile, or if T-Mobile goes down, you can jump on AT&T. Essentially, you can have 2 different SIMs from 2 different carriers for redundancy purposes. When we say resiliency in mind, it's not just about your network, we keep it in mind for our hardware as well at all times.
At the API, we've heard some of the vendors talking about securing these devices in untrusted environments. At the firmware and or via the API, can you disable the USB ports and all the reset switches?
That question has come up before. Currently not,
Okay.
but that's something that I can look at. By default, all the ports can be disabled on the switches, but not on the USB ports at the moment. But I'll do some digging and get you the response. Well, let's take a quick look at some of the different solutions that we have deployed in the past that kind of pertain or may relate to the edge. And I'll start with one of the creative ones, Ansible over Serial. So at some point, the customer called this ZTP over Serial, which is a funny term by itself. But essentially, customers have already solved a lot of problems in data centers, right? They've already written their playbooks. They already have everything in hand. They just want to be able to quickly configure the same things at the edge. And what we do is, a great example of this is your switches and routers are at the edge. They have a console port available. We essentially proxy and become the middleman for your console port. So your Ansible server or your Ansible tower, your playbook is none the wiser. Essentially what happens is it starts executing the playbook as if it's connected via SSH to the router or switch itself. So the benefit of this is you can have a brand new router or switch installed, no network, no configuration on it at all, and you've already spent the time writing the playbook. We're just marrying the two and providing that connectivity for you so you can execute your commands. Another great solution is syslog forwarding over Lighthouse. So what that really means is you can actually nominate the console server as your alternative syslog server on your equipment. And the day that you lose connectivity from your network appliance and your Opengear device to your Splunk server, the Splunk is just an example of a syslog aggregator, but the minute you lose connectivity, you're completely in the dark. You have to start troubleshooting essentially by either doing a truck roll or jumping back in through the Opengear appliance to figure out what's happening. Well, by enabling the forwarding of syslog traffic through us, because we have multiple different ways to get to our centralized manager, you'll have the ability to have full visibility. Even though there's no connectivity, you'll have the visibility and the syslog errors and messages that are coming through the device. So you can immediately know what the problem is. So by the time you're actually making the connection back to start the troubleshooting, you already know all the syslogs and all the errors that were popping up during the event. We talked about Docker, so let's quickly talk about some of the containers that we've tested, deployed, helped customers build. So iPerf is an easy one. You just want to kind of check your bandwidth, see how good your connection is. You can stand this up on either Lighthouse or your operations manager and quickly test connectivity. DHCP and HTTP generally go hand in hand together. And the reason for that is if somebody's doing a DHCP Docker container, usually their intention is to ZTP things. And for that, you need to be able to host the files. So you can either host it on our embedded TFTP server, or you can just simply stand up a HTTP Docker container to host those configurations. And again, just because it's Docker doesn't mean that it's not inside the TPM chip and it's not encrypted. So all this stuff is encrypted, even if it's inside the Docker containers.
Ramtin, quick note. Band 40 is supported on OM 1200.
On the 1200s, it is supported?
Yeah, one of your colleagues just messaged me to tell you that.
Okay, thank you. Band 40 is supported. Somebody
On OM 1200.
got to us. Thanks for.
Yeah, well, thank your team.
Appreciate it. Thanks, team. So another example is ThousandEyes. We're going to be doing a quick demonstration of deploying a ThousandEyes containers on the Opengear appliance, and it's just to show you how quickly you can deploy this and actually start using it. A couple of other examples are, Radius, your AAA functionalities in case your primary connection is cut, you can't get into it, and you still want that security aspect of a different Radius server as a last ditch effort to ensure that you can get into the box. Bind9 for DNS purposes, AWS IoT Core, it essentially creates a tunnel between your operations manager to the AWS server to give you secure connectivity, and Flask and Unicorn for all the GUI fun that you can have with Docker containers. Thousand Eyes. So we talked about it. Again, we're going to do a demo on it, so I'll just quickly talk about this briefly. But essentially, you're leveraging your Opengear as an agent to gather telemetry information. This can be done in-band, out-of-band. Essentially, Thousand Eyes just will use your default gateway. So on a normal day, it's going to go. It's going to use your broadband connection, and on your worst day, it's just going to fail over to cellular and connect back to the Thousand Eyes cloud and actually inform you whether things are working or not. In this example, you can see that the ping off of the Sandy operations manager did not complete, and one of the other devices has been offline for 2 days. So that gives actionable items that you can go in and start investigating. And lastly, we have a feature in our centralized portal called IP access. And what IP access does essentially is provides your remote network admin or your IT admin connectivity to the downstream devices, whether it's through IP or whether it's through serial. So what we're going to demo in a little bit is we're actually going to do a connectivity to an Intel NUC and get into via RDP to ensure that we can troubleshoot the NUC from there.